I'm Saritha Kumari, Assistant Professor of EEE Department, at Institute of Aeronautical Engineering College. Today, my lecture is about problems on mesh analysis and nodal analysis. So, first on mesh analysis. So, mesh analysis, the problem is given with the circuit. So, the circuit is given. You can see here. The question is find the mesh currents. Find the mesh currents for the circuit below. So that means using mesh analysis, we have to find the mesh currents and also currents in each element. There are two steps to apply the mesh analysis. Simple manner, we can say only two steps. Okay. Of course, people may say there are 4 or 5 steps like that. So mesh analysis, we know first step is we have to identify the number of meshes in the given circuit. First step, that is the first step. Then second step is accordingly select the mesh currents. Assume the mesh currents based on the number of meshes. Okay. Then write down the KVL equation in each mesh and solve those equations to find the mesh currents. So see that first step, identify the number of meshes. So here in the given circuit, to identify the meshes means we have to know the clear definition of mesh. So mesh means it is a closed path. It is a closed path without any closed paths inside in it. Okay, mesh means it is a closed path. It is a loop, or we can say. Okay, it is a closed. Exactly to say the correct word is it is a closed path without any closed paths inside in it. So here, looking at this circuit, so we can see that this is a one mesh 1, and then this is mesh 2, and on top we have one more mesh. Okay, so there are in the given circuit there are 3 meshes: mesh 1, mesh 2, mesh 3. So accordingly, then that is the next step. So 3 meshes are here. Okay, so mesh means clear, right? Definition, it is a closed path without any closed paths inside in it. So accordingly, this is one mesh, okay, with inside in it no closed path, and this is second closed path, mesh 2, without any closed paths inside in it. Okay, it has no inside closed paths. So this is 2. Then the upper one is 3. Okay, mesh 3. Okay, now now second step, coming to the second step, after identifying the number of meshes, then we have to assume the mesh currents based on the number of meshes. So here 3 meshes, so accordingly it is taken 3 mesh currents: I1, I2, I1 mesh current I1, mesh current I2, mesh current I3. Okay, so that is a second thing. So that is what it is mentioned. By applying mesh analysis, the given circuit has 3 meshes and the mesh currents are I1, I2, I3. Okay, now see that what is the next thing? We have to apply KVL in each mesh. Accordingly, write down the KVL equation. So there will be a set of equations. So simplify those equations and find the mesh currents. Solve for mesh currents. Okay, that is also nothing but finding the current in each element in the given circuit. So first step, okay, applying KVL. First, applying KVL in the first mesh. Okay, so applying KVL in the first mesh. So here we see that for that you need to know what is a convention. You need to recollect the sign convention for the KVL. So to apply the KVL, we know that there are voltage drops and also battery voltages, battery EMFs. So sign convention is for the voltage drop across the any element. So before apply before write the KVL equation, take the voltage drop direction across each element. So this is supply, starting from supply. So I'm taking this is at higher potential, this is at lower potential. So this plus, this minus. So and then this element I'm taking. So from here, after the next element, after the first element, first this is plus, this is minus. And if you come to this side, so this is connected to battery, second battery negative terminal. So I can take this is minus, this is plus, because this is connected to the negative terminal of the battery. So this is minus, this is plus. And here also on the for the element R4, so this is connected to the main voltage, first voltage source V1. So from there only current starts to flow. So automatically first terminal is at higher potential compared to the second terminal. So that's why this plus, this minus. Now, so voltage drop directions we have taken, assumed. So now, what is a sign convention to write the equation, KVL equation? So if the assumed current direction is same as the voltage drop direction, that is taken with negative sign, okay, and vice versa. And for a battery, if we are moving from negative terminal of the battery to positive terminal of the battery, that is taken, that is nothing but voltage rise, that is taken with plus, and vice versa. That is for battery, okay. Now, so for first mesh, apply KVL, see what is the equation. So this is how it is taken, assumed I1, mesh current I1 started from here, okay, and coming back to the point, starting point. So what is the first element here? 2, resistor 2, and current in 2 ohm resistor is given by I1 and also I3 also there, right? This is I3 in mesh 3. So and the assumed current I1 direction, current is same as the voltage drop direction. So the voltage drop in R2 is given by minus, okay, that is the sign convention. So minus 2 into what is the current in R2, 2 ohm resistor, that is given by difference of I1 and I3, right? So this is first mesh equation I'm writing. So I take I1 is greater, so I1 minus I3, both are in opposite direction. So the current in 2 ohm resistor R2, that is element resistor R2, I1 minus I3, okay. So that is a voltage drop, minus 2 into I1 minus I3. Next, what is a 6 ohm resistor, next element in mesh 1? So this is plus, this minus. So assumed current direction is same as the voltage drop direction. So that is also starts with voltage drop minus. So minus 6 into what is the current in 6 ohm? This 6 ohm. This is given by I1 and I2. Okay, both currents are there. If you look at the directions, both they are in opposite direction. I1 goes down with respect to this R1, and R2 is up. Okay, I2 is up. So current in 6 ohm is given by difference of I1 and I2. So here I am writing first mesh equation. I am assuming I1 minus I2. Okay. So I1 is a higher value compared to I2. That is how I am assuming. So I1 minus I2 in brackets. Okay. Then what is the next element? If you complete the mesh 1, next element is battery. So assumed I1 current direction is from negative terminal to positive terminal. We are going. So negative terminal, lower potential to higher potential means voltage rise. So voltage rise for a battery, we know that in KVL equation that is taken with plus. So that's why plus 50 equal to 0. So that is a first mesh equation, and simplified, that is given by minus 8 I1 minus 8 I1, okay, plus 6 I2 plus 2 I3 equal to minus 50. Okay, that is a equation, say that equation 1. Okay, next. Next. What is the next? We have mesh 2. In mesh 2, what is see that current is I2, mesh current I2. This is the direction I have taken. So now I have started from this point. So the first element is R3 8 ohm resistor. 8 ohm resistor. So what is a first voltage drop? It is given by voltage drop direction is same as the assumed current direction. So minus 8, minus 8. Okay. What is the current? Current in R3 is given by not only I2, there is a I3 also there. Okay. So I3 also flowing. So because it is second mesh equation, because there if you look at the directions, I2 and I3 are in opposite. Okay. For this element. So I2 minus I3. So minus 8 into I2 minus I3. Next, what is the next element if we are moving? So battery voltage 10 volts. So this I2 direction is moving from negative terminal to positive terminal. So that means voltage rise. So again, voltage rise means taken with magnitude plus sign. So plus 10, plus 10. Okay. Then what is the next element in the second mesh? So the next element is R1. Okay. So 6 ohm. So here if you look at the direction of assumed current I2 direction with the voltage drop direction, okay, they are opposite. I2 is moving, okay, up, but voltage drop is given by, this is minus, this is plus. So they are opposite. So that's why it starts with voltage drop plus. So plus 6. Plus 6. Already we have taken the current in 6 ohm resistor is I1 minus I2. So that is given by plus 6 into I1 minus I2 equal to 0. That is the second mesh equation. Further simplify and say that equation number 2. So the equation is given by 6 I1 minus 14 I2 plus 8 I3 equal to minus 10. That is a equation 2. Okay, next coming to the next mesh, third mesh. This is a third mesh. So in third mesh, started from here the mesh current. So that's why what is the first element? R4. So the I3 current direction is same as the voltage drop direction. So the first voltage drop is given by minus 10, minus 10 I3. Okay. Next element in mesh 3 is given by this R3 8 ohm. Okay. If you look at the voltage drop direction, so this is opposite to the I3 direction, right? I3 is moving like this. So here the first terminal is negative. So it is the I3 assumed current I3 direction is opposite to the voltage drop direction. So that's why it is taken with plus. Plus 8 into what is the current in already in this element we have taken I2 minus I3. So plus 8 into I2 minus I3. Next, complete the mesh. So if you are going to, if we are moving, the next element in mesh 3 is given by this R2, 2 ohm resistor. So look at the direction of mesh current I3 direction with respect to voltage drop direction. So the I3 is moving like this, but the voltage drop direction is, this is minus, this is plus. So they are opposite. So that means plus voltage drop direction here in the equation plus, right? Plus 2 into what is the current in this element? Already we have taken I1 minus I3. So plus 2 into I1 minus I3. So simplify. Next step, already we have equation 1, okay, in mesh for mesh 1, and equation number 2 for mesh 2, and now this is the mesh 3 equation simplified. Further simplified, the equation is given by 2I1 plus 8I2 minus 20I3 equal to 0, and say that equation number 3. So 3 equations, 3 unknowns and 3 equations, 3 unknowns. So solving these equations, we are able to give the values of I1, I2. We are able to get the values of I1, I2, I3 using a scientific calculator. We are simply able to calculate. So the values, finally the values of I1, I2, I3, which are the mesh currents. So the values are given by I1 is 16 amperes, I2 is 11 amperes, I3 is 6 amperes. So that is how the mesh currents are calculated, okay, for this circuit. Okay. So for this circuit, this is how the values mesh currents are calculated. Okay. So which is a 3 mesh circuit. That's why we have the 3 equations we have accordingly. So that's why a little bit big problem, we can say. So next problem on the mesh analysis only. uh, this is a circuit, you can see already, which is see that this is a next problem on mesh analysis, you can see. So in this circuit, okay, this is compared to the previous problem, little bit small. So this is a circuit given with the battery voltages, okay, battery emfs, and resistances values 2 ohm, 4 ohm, 3 ohm. Okay, so the resistance values, okay, 2 ohm, 4 ohm, 3 ohm. So now, okay, the problem is same. Applying mesh analysis, find the mesh currents. So here steps are mentioned. Just steps are mentioned. What are the steps? Okay, given already we know the simple, in a simple, already I mentioned only two steps in a simple way. Of course, people sometimes they also clearly they write in terms of 5 steps. So steps: identify the number of meshes. Okay, loops means meshes. Exact word is meshes, because there is a small difference between loop and mesh, right? So mesh means a closed path without any closed paths inside in it. That is mesh. Okay. Loop means it is a closed path which may have other closed paths inside in it. That is a loop. Okay. So for clarity, I am correcting this. So first step, identify the number of meshes. Okay. Next step, accordingly select the mesh currents. Right. Select the mesh currents and apply KVL in each mesh. Write the equations and solve them to find the mesh currents and unknown currents. Okay, that is what they mentioned, 5 steps. Okay, identify the number of meshes. Second, give the mesh current directions. Okay, then apply KVL in each mesh. Fourth one, find the unknown mesh currents, right? Solving those equations by solve those equations. And last one, find the unknown values, unknown currents. Okay, current in each any element, not only mesh current. Okay, we can find the current in any element in the circuit using the mesh analysis. Okay, so this is a circuit. So here we are identifying the number of meshes are 2. Okay, so already it is mentioned, it is shown, you can see mesh 1, mesh 2, right? Yes or no? This is one mesh, this is one mesh, next one beside one is mesh 2. Okay, simple, okay, simple circuit. So directly we can say only 2 meshes. Accordingly, what are the mesh currents? 2 meshes means 2 mesh currents, I1, I2. Okay, and then and then and the direction of those currents also we have to assume. So I1 I have taken like this, it is clearly shown with pink color line. So I1, it is started from here and going like this and coming back to the starting point. And I2 started from here going through the mesh, okay, and coming back to the starting point. Okay, so that is directions assume. Now apply KVL and write the equation in each mesh. Okay, and solve them. Okay, so for first mesh 1, so here started. So mesh 1, we are moving. This is a battery. We are moving negative term from negative terminal to positive terminal. So voltage rise. So that's why plus 5 plus 5. Next, what is the element? If we are moving in the mesh 1, next element is 2 ohm resistor. Okay, so take the sign conventions, voltage drop, polarities, just mark them for the clarity. Okay, So this 4 ohm resistor also, this is battery plus terminal, it is connected. So this is plus, this is minus, right? Now, so after in the first equation only, mesh 1, 5. Next element is 2 ohm resistor. What is the voltage in 2 ohm resistor? 2 into what is the current there? I1. So 2 I1. Is it plus or minus? Your assumed direction is same as the voltage drop direction, right? I1 is moving like this, going from this terminal to this terminal, which is same as the voltage drop direction. That's why minus. So equation minus 2 I1. And then what is the next element? 3 ohm resistor. Current in that is given by, see that, okay, first look at the sign. So current direction I1 is same as, it is moving, it is going like this I1, which is same as the voltage drop direction. Okay, so that's why minus 3 into what is the current in this 3 ohm now. Like look at the directions of I1, I2. I1 is moving like this from top to down, up from top to bottom, and I2 also going from with in a 3 ohm resistor from top to bottom. So they are both are in the same direction. That's why current in 3 ohm resistor is given by addition of those two currents. So minus 3 into I1 minus I2. Okay. So that is a mesh 1 equation. Okay. So now simplify. Further simplify this. So this is given by 5I1, 3I2, 5I1, 3I2 equal to 5. Say that equation 1. Okay. Now, next is mesh 2. Mesh 2 KVL equation. So started from here, mesh 2 started here. So look at the first, what is element? Battery EMF. So we are moving from negative terminal to positive terminal. So that means voltage rise. So voltage rise means in the equation plus 10. And then next element is 4 ohm. So I2 direction is same as the voltage drop direction of 4 ohm resistor, right? I2 direction like this. So minus 4 I2, minus 4 I2. Then what is our next element? This 3 ohm resistor. So I2 direction is same as the I2 we have taken like this, right? I2 direction is same as the voltage drop direction. Okay, for second mesh also. So minus 3. Okay, minus 3 into what is the current in 3 ohm resistor? From the circuit we know that I1 plus I2. Okay, already we know based on the direction, that is both are in same direction. So that's why sum of the I1 and I2. So simplify that and the equation is 3I1 plus 7I2 equal to 10. Okay. So that is, let us say, equation 2. Okay. So 2 equations, 2 unknowns. 2 equations, 2 unknowns. Okay. So solving them, I1 value is given by 0.192 amperes, I2 value is given by 1.346 amperes. Okay. So these are the values of I1, I2, which are also nothing but mesh currents. Okay. So mesh currents values solved. Okay. So that is how this problem is solved. Okay. Next we have problem on nodal analysis. So see that nodal analysis, we know that using nodal analysis we can find the currents and voltages. Okay. Current in the given circuit, we are able to know the voltage of any element, voltage across any element, and also current in any element. Okay. So to apply the nodal analysis, we have to recollect what are the steps. Okay. Here also in simple manner we can say only 2 steps. Okay. Nodal analysis. In detail people say there are 5 steps. Okay. In a simple manner I say there are only 2 steps. What is the first step is, in nodal analysis we have to identify the number of nodes present in the given circuit. That is the first step. Okay. Important one. And then second step is, okay, after identifying the nodes, we accordingly take the nodal voltages. Okay, one is reference node, that is the first step, and second step is assume the currents in each element and apply KCL at each node. Okay, apply KCL at each node, okay, by assuming currents in each element, and write the equations and solve them. Write the equations and solve them to find the nodal voltages and then currents. Okay, so here look at this problem, a small circuit. It is, so identify the number of nodes, identify the nodes. Second step, mention the node voltages, right? Based on the number of nodes, take the node voltages. Node voltage, if there are two nodes, node voltages are V1, V2, like that. Okay, so node voltages V1, V2, like that if there are two nodes. Okay, and one node is reference. If only two nodes are present in the given circuit, one node becomes reference node and only we have node voltage 1, V1. Okay, and next apply KCL at each node. Okay, find the unknown node voltages and then unknown currents, unknown values of currents. Okay, now look at this circuit. This is a circuit given. There are battery voltages. This is 5 one side, and the other side you can see there is a second battery voltage 10 volts, and resistors are, this is 2 ohm, this is 4 ohm, this is 3 ohm. So uh, so that is the circuit given. So apply nodal analysis, find the, okay, find the nodal voltages and also currents in each element. So here first step I'm going, identify the number of nodes. So for that you need to know you need to recollect the definition of node. Node is nothing but it is a common point where more than two circuit elements are connected, right? It is a common point where more than two circuit elements are connected, that is called node. So here if you look at the if you start from the supply battery, first point is not a node. No, okay, yes or no? Node means more than two circuit elements. So but at this only two elements, so this is not. Next element, this is a node, one node, yes or no? More than two circuit elements. Okay, so node 1. Okay, now next, this is not a node, this is not a node, and this is a another node, yes or no? More than two elements connected, because we can see clearly, that's why it is second node, then this is not a node. So how many nodes? Only we have two nodes. One, this is 1, this is 2, right? Node 1, node 1, node 1, node 2. Now after identifying number of nodes, okay, we have to select node voltages. Okay, so node voltage 1, node voltage 2, right? V1, V2, and after that we have to take one node as reference node. Okay, so V2 here it is taken as reference node. Okay, and reference node is nothing but whose potential is at 0. That's why V2 is equal to VR, that is nothing but equal to 0. Okay, so for this circuit we have only one node voltage, that is V1. Okay, now that is the first step over. Next, second step, apply KCL at each node by assuming currents in each element. So here started from this element, from the supply battery, first element is this one, so current in this is taken I1. So the direction, because this is supply, so current starts to flow from this battery, so that's why the direction of I1 is taken like this. Okay, so that is our choice only, but just basic understanding we have, that's why I1 direction is taken like this from the, okay, direction. Next, from this I1 only current flows to the next element, that's why I2 direction taken like this down. And I3, if you look at the I3 direction, because the other side there is a one more battery 10 volts, so that's why the current in the 4 ohm resistor, which is say I3 whose direction is taken like this. So it starts to flow from this 10 volts. That's why like this the direction of I3 taken. Okay, now so that's all. Then there are no more elements. So now after taking the currents, assuming currents in each element, we have to apply KCL, right, at each node and write the equations and solve them. So we have at node 1, at node 1, at node 1 applying KCL, applying KCL. So see that. So we know that KCL means sum of algebraic sum of currents, algebraic sum of incoming currents and outgoing currents is equal to 0, right? So and sign convention is incoming currents are taken with positive sign, outgoing currents taken with negative sign. So at node 1, incoming current is I1. Okay, that's why I1, which is incoming I1, and I2 is leaving current, so minus I2. And the incoming I3, if you look at the I3, that is also coming towards. So that's why plus I3. Okay, so that is a equation. Now substitute these currents in terms of the node voltages, right? Node voltage and battery. Battery is EMF. So I1 is given by 5 minus. So you look at the direction. So according to based on Ohm's law. So 5 minus V1, right? 5 minus V1 by 2. That is I1. Okay, next I2. If you look at the circuit, I2 is given between 1, node voltage 1 and reference node, which is value is 0. So V1 minus VR. V1 minus 0 by 3. That is I2. Then I3 is given by 10 minus V1 by 4. 10 minus V1 by 4. Right? So that is a I3 value. So finally, that is how in terms of node voltages using Ohm's law it is written, the currents are written. Now simplifying this equation we have, okay, one equation, one unknown, which is V1. So that is calculated. So whose value is given by 4.615 volts. 4.615 volt. So after this after this node voltage value calculated, okay, here we have only one node voltage which is V1 calculated. Find the currents. Okay, know the currents. Okay, I1, I2, I3. So I1 is given by, we know that 5 minus V1 by 2. Okay, so 5 minus 4.615 by 2 means whose value 0.192. Okay, then I2 is given by, what is I2? V1 by 3, right? So 4.6 by 3, 1.538. Next, what is I3? 10 minus V1 by 4, right? 10 minus 4.61 by 4, whose value is given as 1.346. So that is how using nodal analysis, node voltages are calculated and also currents in the circuit, currents in each element also calculated. So thank you.
Like, share and subscribe. Hit the bell icon for more updates.